Okay, guys. So the example for the CP, which will be basically your final task, it's a simple example. Is just a vertical pipe uh, with the following characteristics to receive cathodic protection. Is a vertical pipe is uncoated, it's very still. The pipeline has different environments. It goes, imagine a pipeline that goes from the air and it enters the sea and then past the sea, and then when it leaves the sea, it's just very short distance. And when it leaves the sea, it passes through mud and then it goes outside. So the diameter is basically 0.6 meters. The wall thickness is 19 millimeters. And those are the characteristics. At the end, we have an aluminum zinc indium type of anode. We have the anode potential, the operational potential requirements, which is minus 1.1. This is important. We will utilize that number. Basically, all the numbers here are of use. The numbers there is just for comparison, and we will see. The design life is 20 years, so we need to consider that at the end to take the final conclusions. As I see, we have the seawater. As I said, we have the seawater, initial, average, and final, and we have the mud, initial, average, and final. And this is the current density when they have 25. So how we start? We start with this equation, the corresponding current demand. So remember the maintenance, the corresponding current demand is this equation, which is the current required in amps, current density required, surface area, and coating breakdown. Basically, what I want you to do is put the numbers there to get these results. You have the initial maintenance number is the average number. So I will go back, and the average number is the seawater average, seawater initial. And then we have current demand in mud, initial, maintenance or average, and final, which is basically the final. So seawater initial, seawater average, seawater final, and the same there. So you will take the numbers there, and then you will give me that stuff. And you will basically need to know, because it's a conversion and how these things will be utilized there. The next thing that we need to know is the total net mass of the anode material. This is now with the numbers. So this is you just basically need to copy, but you need to know which numbers came from. So we have M. You need to go back to the other video, and that's basically said the current in maintenance, time, hours, utilization, and efficiency. All the numbers are done. So basically what it happened is you need to calculate the mass of the anode to provide this corresponding current demand. When you calculate this, you will realize that you will need an anode that has an equivalent weight or a weight of 117 kilograms. You can cast the iron, or you can go and buy from a vendor. If you buy from a vendor, he will give you the typical anode that they have on display, which is, or they have that they construct or they cast, which is an anode with 119 kilograms of aluminum, 60 inches length with that radius and with the steel core diameter. And with a utilization factor of 0.85. As we discussed in the last video, utilization factor, it means how much of the anode at how long it's utilizable, or it's basically it has a demand that we require. Of course, when it goes on corrosion, the anode is losing all these properties, but until it reaches the 85, then it's not any longer reliable. And then we need to dispose that anode, okay? So we have the mass there. How we need to move? So we need to move there. We need to calculate the resistance. As we said, we are using the Dwight formula, which is there. You know what, you can go back and then you can see which are everyone. And then we need to know the length, which is the final, and the final radius. So we need to calculate for the initial, what is the initial resistance and what is the final resistance there.